Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 7. This is Section 15.2, Problem number 7. We want to solve the integral of dx over x minus 5. Now what makes this kind of tough is the minus 5 in the denominator with the x. If it was just dx over x, I could solve that. The minus 5 makes it a much tougher problem. So again, to solve this, I need to use the substitution method. So we need to make a substitution. U equals, now, of the choices we have, the only one that fits is really the stuff in the denominator. A very typical choice is the stuff in parentheses. There are no parentheses in this problem. Stuff under the root, there's no root in this problem. Stuff in the denominator, bingo, it fits. Power of e, there's no e. So it really has to be what's in the denominator. It's the only choice that fits. And what's in the denominator is x minus 5. So that's my value for u. Next will be du, which will be the derivative. So the x, or 1x to the first power, gives me a derivative of 1. Right? When you have an x to the first power, the derivative is the number in front. The number in front isn't written, but it's assumed to be 1x to the first. The minus 5 has no x with it, so its derivative is 0. It just goes away. And at the end, you put dx for derivative with respect to x. And 1 dx, you don't really need to bother to write the 1. Just say du equals dx. 1 times dx, of course, is dx. 1 times anything just stays the same. So now as I rewrite this problem in terms of my new variable, dx on the top is a perfect match for du. And in the denominator, x minus 5 is a perfect match for u. So I have du over u. Now I'd like to write that as u to the minus 1 du. Again, I don't want to have a variable in the denominator. Now, when I go to take the integral, actually solve the integral, typically what happens when I have an exponent is I do the number in front of the variable, which in this case is 1, over the old exponent plus 1 variable, old exponent plus 1 power. But what happens here is 1 over negative 1 plus 1 is 1 over 0. 0 in the denominator. Bad, bad, bad. So that's a flag that you missed one of the formulas. Something went wrong here. When you have the exponent to the negative 1, it's a special case we have to use the natural log. Any other negative exponent's fine. Negative 3, negative 8, you can do that same process. But negative 1 has its own special case because of the 0 you get in the denominator. So the answer would be the natural log of the absolute value of u plus a constant. And again, because the original question wasn't asked in terms of u, you have to put it back to x. I know what u is equal to. It's equal to x minus 5. So my final answer will be the natural log of the absolute value of x minus 5 plus some constant.